Hello, young math padawans. It's Mrs. Angel with your lesson for today on factoring trinomials. So we're going to be looking at a very specific method called the P's and Q's method. And it's named after a game that we play sometimes in math called the P's and Q's game. So there were some notes that go along with this. You're definitely going to want those in front of you. Grab those notes and let's get started. So we're going to get started today with a quick warm-up on multiplying binomials. So if you don't recall, multiplying binomials, there are two different methods, the double distribute method and the box method. We'll go ahead and just recap those two methods on this first one. So double distribute means I take the first term from the first binomial x, and I'm going to multiply it by the entire second binomial x plus 4. And then I'm going to take the second term from the first binomial, a positive 3, and do the same thing. Multiply it by x plus 4. Now we use our distributive property. X times x is x squared. X times 4 is a positive 4x. And our second distribute, 3 times x is a 3x, and 3 times 4 is a positive 12. Now, you might notice that we have some like terms that can be combined. So we're going to go ahead and combine that 4x and that 3x with our final answer of x squared plus 7x plus 12. Now the other method that we could have used here instead is called the box method or the window method. So the window method, you take that first binomial and you're going to place it across the top. So we're going to break that first binomial up into x and positive 3. Then you take the second binomial, x plus 4, and you're going to write it across the side. So we're going to have x and our positive 4. Now we're going to find the area of each space. X times x gives us x squared. X times a positive 3 is a positive 3x. X times a positive 4 is a positive 4x. And positive 4 times positive 3 is positive 12. Now what I like to do is when I pull all of these terms out of the window, I see that I have a positive 4x and a positive 3x. So I'm going to combine those as I pull the terms out. So the term with the greatest degree is x squared. A 3x and a 4x combine to a 7x, and there's my plus 12. And you'll notice that it's the same no matter which method you're using. So go ahead and complete the next three on your own using either the double distribute method or the box window method. Great. Take a moment and see how you did on each of these. Okay, hopefully that gave you a chance to check your work and then maybe make some adjustments to your work if you made a mistake here or there. So what we're going to do now is we're going to actually look at some patterns or some observations with each of these products. So what do we notice about what we start with is with our product of two binomials and what we end up with? And there's actually a pattern here that happens every time. So let's look at this first one. So in number 1, we started with x plus 3 and x plus 4. And after we multiplied, we ended with x squared plus 7x plus 12. Now, if you look at what's happening in both methods, at some point or another, we end up multiplying 3 and 4 together, right? We end up multiplying 3 and 4 to get 12 in double distribute, and we multiply 3 and 4 to get 12 in our box method or our window method. So we can say that this last term 12 comes from multiplying a product of 3 times 4. So eventually we're going to multiply 3 by 4, and that is how we got 12. Now my question for you is, how did we end up with 7? Well, what happens here is that you end up multiplying 3 and 4 by an x term. So you end up having a 4x and a 3x, a 4x and a 3x, and those are like terms, so we end up adding those two together. So this middle term is the sum of 3 and 4. So that's an interesting observation. Let's see if that same pattern applies to all of the other examples here. So let's take a look here at number 2. In number 2, again, we started with x minus 5 times x plus 6, and after multiplying, we got x squared plus 1x plus 30. Well, at one point or another, we multiplied our positive 6 and our negative 5 to get negative 30. So that term is the result of multiplying our two constants. This is the product of negative 5 and 6. Interesting. And then where did our plus 1 come from? Well, that came from adding a 6x and a negative 5x because we ended up multiplying a negative 5 and a positive 6 by x and combining them together. So this was the sum of negative 5 plus 6. Interesting. Can you go ahead and see if that same pattern applies in numbers 3 and 4? Did you find the same pattern here? Well, let's see. Our numbers are our constants, and our binomial for number 3 are a positive 7 and a negative 2. Well, how did we end up with negative 14 here? We multiplied positive 7 by negative 2, and that's how we end up with negative 14. So this final term here is the result of the product of 7 and negative 2. And then how did we end up with a positive 5x? Well, it's because we ended up adding some like terms, a negative 2x and a positive 7x. So this is the result of the sum of 7 and negative 2. So the pattern also applies there. What about this one in number 4? Well, where did that positive 4 come from? That came from multiplying our two constants here of negative 1 and negative 4. Because negative 1 times negative 4 is positive 4. So this was the result of multiplying those two constants. And then where did the negative 5x come from? Well, that came from doing a negative 4 and a negative 1. This was the sum of our two constants, negative 4 and negative 1. So why is this important? This is important because these types of problems work in both ways. In this warm-up, I asked you to multiply two binomials to end up with a trinomial that's in simplest form. But what if I gave you a trinomial and instead asked you to find those two binomials? That is called factoring. It's basically the opposite of multiplication or undoing multiplication to put something back into a product. So we're going to use this pattern, this observation that we just found, to factor some trinomials and put them back into things that look like this, a product of two binomials. Now, before we can do that, we're going to play a little game. I like to call it the P's and Q's game, and it's just a numbers game to kind of get our minds used to this idea of sums and products. So here's how the game works. I'm giving you some variables P and Q, and I'm giving you some information about P and Q. For example, here in number 1, I say that P times Q is 24 and P plus Q is 11. So what are the values of P and Q? So we have to find two numbers that have a product of 24 and a sum of 11. So I started thinking here and I'm like, okay, well, what two numbers have a product of 24? What about 2 times 12? That equals 24. But does 2 plus 12 equal 11? Shoot, that doesn't work. Okay, so 2 and 12 aren't my values of P and Q. What about 6 and 4? 6 times 4 is 24, but does 6 plus 4 equal 11? No, that doesn't work either. What about 8 and 3? 8 times 3 equals 24, and does 8 plus 3 equal 11? Yes, so we've just found the values of P and Q. The values of P and Q here are 8 and 3 because 8 times 3 is 24 and 8 plus 3 is 11. So now it's your turn to play the game with 2, 3, and 4. Can you find the values of P and Q in these three examples? Now you might be thinking, why did we just randomly play that game in the middle of this video? Well, when we're factoring, we're going to end up using this observation from before. We're going to look at specific number pairs that have a sum and a product in common. So the values of P and Q. Let's see what that looks like in our practice. Find the width and the length of each rectangle, multiply to check using the double distribute or the box method. So here, we're trying to find the width and we're trying to find the length, but now we have trinomials that don't have a greatest common factor. So what we're going to do is we're going to use the pattern that we saw in our warm-up and that P's and Q's game to find our length and our width here. So let's take a look here at number 1. So our area is m squared plus 8m plus 12. And we need to find our length and our width. So essentially, we need to find the product of two binomials that when we multiply gives us this trinomial. So if we recall from our warm-up, there's a pattern here. The middle term, this 8, is always the sum of our two constants. And that last term, that positive 12, is always the product of our two constants. So what we're going to do is we're going to play the P's and Q's game. What two numbers have a sum of 8 and a product of 12? Thinking 4 times 3 is 12, but 4 plus 3 is 7. What about 6 and 2? 6 times 2 is 12, and 6 plus 2 is 8. Okay, but what do we do with that information? Well, we're going to take this trinomial and rewrite it as a product. We're going to have a binomial times a binomial. One of those binomials will be our length, and the other will be our width. So we're going to take these two constants, these 6 and this 2, and those are going to be our two constants in our binomials. We have a positive 6, and we have a positive 2. And then what's the first term going to be? Well, what times what will give you m squared? That would be m and n. So if we're correct here, we could say that our width is m plus 6 and our length is n plus 2. But before we can put those in our diagram, go ahead and multiply to check using either double distribute or the box method. So it looks like after you check that you end up with m squared plus 8m plus 12. So this is correct. So that means that our width or our length, it doesn't really matter, one of our sides is m plus 6 and our other side is m plus 2. Let's try another example. Here is number 2. We're given the area x squared minus 3x minus 54, and we have to find the length and the width. So let's use what we know. The middle term here is our sum, and the last term here is our product. So we just have to play the P's and Q's game, okay? Well, what plus what will give me negative 3? That when I multiply them together gives me negative 54. This is kind of a tough one. I don't feel like a lot goes into negative 54. What goes into 54? Oh yeah, 9 and 6. So I know 9 times 6 is 54, but one of them has to be negative in order to get negative 54. Which one? Let's try making 9 negative and see if that works. Negative 9 times 6 is negative 54, and negative 9 plus 6, that's negative 3. Awesome. So let's set up our product of two binomials. We now know that the first one will have a constant of negative 9, and the second one will have a constant of 6. But what's our variable going to be? Well, we have x squared here, so what times what is x squared? X and x. But before we put it into our diagram, go ahead and multiply to check now. So that means that our two binomials are correct. So place one of the binomials along the width and the other binomial along the length. And there we have it. All right, your turn. Why don't you go ahead and try doing number 3 and 4 on your own now. All right, so I went ahead and started number 3. I found that the two numbers that have a sum of negative 5 and a product of 4 were negative 1 and negative 4, but go ahead and check my work if you haven't already. Okay, so it looks like it checks out, which means that one of my side lengths, either the length or the width, could be h minus 1, and the other one would be h minus 4. And the order doesn't matter because you're going to end up multiplying them anyways. Now, you may have struggled a little bit with number 4, and that's very common. Number 4 is a little tough because that middle term doesn't have a coefficient. So what is the sum here? Well, if you recall, every term has a hidden 1. So we're trying to find two numbers that have a sum of 1 and a product of negative 2. But that doesn't make it much easier. Like, what plus what equals 1? Well, focus on the product. What times what is 2? The only combination of that would be 1 and 2. But because it's negative, one of those has to be negative. So let's try making 1 negative and see what happens. -1 times 2 is -2, and -2 plus 1 is 1. So that worked. So let's go ahead and write out our product of two binomials. We're going to make the constant -1 in the first and +2 in the second. And that order doesn't matter. If you put +2 first and -1 second, it's fine. And then what's going to be my variable? Well, what times what is k squared? K times k. So before we can put it into the diagram, go ahead and check that now. All right, so it looks like that works. And then just remember, anytime you have a 1k, you can always get rid of just that 1, and then you'll be left with a variable by itself. Okay, so that means that our length or our width, it doesn't matter. One of our sides is k minus 1, and the other side is k plus 2. All right, your turn. Go ahead and try numbers 5 and 6 on your own now. Okay, so let's quickly recap. What we did in this video is we took something that was in simplest terms. We took a trinomial and we factored it. We wrote it as a product of two binomials. So the way that we did that is we noticed that the middle term of the trinomial is always the sum, p plus q, which are just variables for our constants. And the last term is always our product, p times q. And once you play the p's and q's game, then all you have to do is write it as a product of two binomials, where that first term is always going to be whatever the variable is, and the second terms are going to be your values of p and q. Finally, before you do anything else, always multiply to check. That's it for today's lesson. I will see you next time.